Thank you very much. I just want to set the scene, really. People often ask me, what is left to explore? What is the role of exploration these days? And I would say that the classic era of exploration, where we were delineating where the coastlines were, where are the mountains, where are the coastlines, where are the ice caps, and so on, that phase is largely over. Terrestrial exploration, working out where everything is done. But filling in the detail is the role of modern exploration, for it is in the detail of understanding how these environments, these ecosystems work, that if we can understand how they work, we are going to be in a better position to manage our relationship with the environment generally and with specific ecosystems. So I think that this Catlin Arctic survey is a classic example of where the future lies for exploration. We all know that there's sea ice cover on the Arctic Ocean in the region of the North Pole. But what we need to know now is much more detailed information so that we can understand what's really going on there. And I have spent the last 20 years traveling on the sea ice. Few people in the world will have spent more time actually traveling on sea ice. And it became an increasing source of frustration to me to be doing that and it not really being of any great value to the wider world. And I realized in talking to scientists that there was some information that would be particularly helpful in looking at the time frames for how much longer we might have sea ice cover on the Arctic Ocean as a permanent surface feature on our planet. It occurred to me that the bizarre range of skills, to most, could be applied usefully to gather this information. In fact, myself and a small number of people around the world are the only people who can gather this information, which is to take direct measurements at the surface of the sea ice and establish its thickness. Now, there are other systems used, remote sensing platforms from satellites and also from submarines more accurately. But there is a special value in taking measurements at the surface. So the Catlin Arctic survey was a pioneering international scientific endeavor where explorers were working with scientists, the University of Cambridge in particular, and organizations specializing in communicating the bigger messages, the WWF, and this three-way partnership is the full expression of what I feel exploration is about. It finds out information that others cannot. It passes on to the scientists who grind their way through the data to produce the findings, authoritative findings, and then there are others that can then communicate those findings and don't end up in a dusty drawer in an office somewhere. The route that we did was selected by the University of Cambridge and others. It was in a sea area that was of particular interest in terms of what is going on. We wanted to find out particularly what was going on in this sea area with relation to sea ice. We covered about 450 kilometers. It took, as Rod says, about 73 days. The temperatures for the first 40 days were in the minus 30 to minus 45 degrees centigrade bracket. We were traveling for half the day on average and then surveying with a manual drill the other half of the day. Our aspiration was to drill about up to 10 holes through the sea ice each day, subject to weather most particularly. We were actually surveying in temperatures with a wind chill sometimes, but below minus 70 degrees centigrade, and at night with head torches. We were traveling at night with head torches, and we were surveying at night with head torches in early stages of the expedition when the sun is well below the horizon for much of the daytime, in inverted commas. You can begin to see, perhaps, when I throw in the fact that we were swimming some of the time as well in immersion suits, that this is a job that is probably not best done by those who are more accustomed to dealing with the findings than gathering of the information. which is not to say that some scientists aren't extremely tough, obviously. The project, I think it's worth saying, the project had three substantial goals. At its epicenter was the science, which we're going to go into now, but also it was about communicating to the widest possible global audience what is going on up there. It's a place that few people go to, few people really understand, but I am here, and so are my colleagues, to explain the significance, not just what is going on, but the significance of what is going on in this remote part of the world. The surveying involved about 6,000 discrete measurements and observations. About 1,500 of them were associated with the drilling, and about 4,500 of them were associated with visual observations. So as we were traveling, we were recording every surface feature that we encountered, every ice flow, where the ice flows have crunched together to throw up what are known as pressure ridges, these chaotic jumbles of ice, linear ridges of ice. Every single one of those was recorded and various measurements made of it, and every area of open water or very thin ice. This combination technique of manual drilling associated with visual observations while traveling during the day, in combination, they have enabled the University of Cambridge to make some deductions about ice thickness and ice thickness distribution, which we'll hear about now. And at this point, I would like to hand over to Peter Wadhams and his team, who have been processing our data. Thanks, Peter.
Whilst Peter and